Alright, we're going to get started again here today with our lecture notes on the Pythagorean Theorem. You should definitely have something to write with and your calculator and your lecture notes in front of you. You should pause the notes right now. If you don't have those things, get them in front of you and then get back with me, and we're going to get started. Looking at the converse of the Pythagorean Theorem. That means it's pretty much the opposite of the Pythagorean Theorem. All right? So the Pythagorean Theorem once again states that if a triangle is a right triangle, that means it has a 90-degree angle, one of its angles is 90 degrees, then a squared plus b squared equals c squared. Okay, again, let's remember that a and b, we call these legs, and c, we call this the hypotenuse. Right? So the two legs, the sum of the squares of the legs is equal to the square of the hypotenuse. The hypotenuse is the long side that is opposite of the right angle in the triangle. Okay, the legs are adjacent to the right angle. So again, it looks kind of like this. Right, your right angle's right here, sides A and B, it doesn't matter which one's which. And then C is the hypotenuse over there. Okay. Well, the converse of the Pythagorean theorem states that if a squared plus b squared equals c squared, the triangle is a right triangle. Okay. So all that's saying is if we know the lengths of A, B, and C, the legs and the hypotenuse, well then we can figure out whether or not this angle right here is a right angle, a 90-degree angle. And again, C is always going to be the long side. Okay, so as we look at this table here on the other side, it says, verify that the following sets of lengths make the equation a squared plus b squared equal to c squared true. Record your results in the table. Okay, so all it's really asking us to do is look at these values. We've got A and B. Those are the legs. If we square those and add them together, right, if we add them together, then it should equal c squared. Okay, so that's all we're trying to do. And it says, is a squared plus b squared equal to c squared true? Is that true? So we replace a with 3 right here, and we square that value, and we replace b with 4 right here, and we square that value, and we do the same thing with 5. And we find that 3 squared plus 4 squared is equal to 9 plus 16. 3 times 3 is 9, 4 times 4 is 16. And then 5 squared is 25, right? We can check all that with our calculators, and you guys, you know how to use those things, right? You know how to square numbers. 5 up 2 equals, and then there you have it, right? That does it okay for you. Let me see if I can use that a little bit better. See that calculator? So that is a right triangle because 9 plus 16 is in fact equal to 25, right? 9 plus 16 equals 25. Well, there we go. So that's a right triangle. And we're doing the same thing with all the values in this table. If the triangle has legs of 5 and 12 and a hypotenuse of 13, well then it is a right triangle because 5 squared is 25 and 12 squared is 144 and 13 squared is 169. And if I combine 25 and 144, I get 169. So yes, this is again a right triangle. And we continue doing this with all the rest of the values in the table. 7 squared plus 24 squared equals 25 squared. Is that true? 49 plus 576 does in fact equal 625. 49 plus 576 equals, and check them out for yourself. Type those into your calculator, right? 8 squared, 8 up 2 plus 15 to the second power equals 289. Well, 17 to the second power also equals 289. So 8 squared plus 15 squared equals 17 squared. So that would be like saying A is 8 and B is 15, and C is 17. Okay, just a little example using that diagram at the bottom. And the last one in the table there is 20, 21, and 29. Legs are 20 and 21. Square those values and add them together. You get 841, and if you square 29, you get 841, right? And squaring and finding square roots are just inverse operations. That's 841. We should get 29 here. There we go. Right. 29 squared is 841, and 841, the square root of 841 is 29. Yes, that is a right triangle. And these little diagrams down here at the bottom are really helpful in understanding that whole thing, right? Your right angle is right here. You've got a side of 5 units, and then you've got a side of 3 units and a side of 4 units. Okay, that's a 3, 4, 5 triangle. Again, 3 squared equals 9, and 4 squared equals 16, and 5 squared equals 25. Okay, and 9 plus 16 does equal 25. This is a right triangle. Okay, we're going to continue moving with the converse of the Pythagorean theorem. Let's see here. I'm sorry. I just bungled a little bit here, but we're back. Okay, everyone's looking at this page right here, and it's kind of the same thing. We're trying to figure out if each one of these triangles is going to be a right triangle. Okay, and we just use the Pythagorean theorem. We plug these values in. Right? I'm going to substitute 9 for A and 40 for B, and I'm going to put 41 in place of C. And I know that has to be C because the hypotenuse, or C, is always the long side. That will be opposite of the right angle. Okay, so we substitute those values over here into the Pythagorean theorem formula. 9 squared is 81, 40 squared is 1,600, and 41 squared is 1,681. You can see when you put those two together, they are in fact equal. So this is a right triangle because the sum of the squares of the legs is equal to the square of the hypotenuse. The hypotenuse is the long side. The legs are adjacent to the right angle, right? So that triangle looks just like this. Well, definitely not to scale, but 41 is your long side, or C, and that's opposite of your right angle right there. And here's another side. That's B or A, doesn't really matter. And then A is equal to 9. Okay, and that's what that one looks like. And if we look at the next example to figure out if it's a right triangle or not, we're going to do the same thing, right? We know, let's see, the long side right there, 12 meters, is going to be C. And these other ones don't really matter where I put them. Okay, we'll call A 8. 8 squared is 64. We'll call B 10. 10 squared is 100. And if I add those two together, I get 164. Well, my third side of the triangle is 12, and 12 squared, or 12 times 12, is 144. And those values are not equal, so this is not a right triangle. One of those angles is not 90 degrees. Okay, if I'm going too fast, you should pause the video and get what you need. Stop it, rewind it, go back. I'm going to go over to the other side of that page, the next set of problems here. We're working on the same thing, right? You've got the same thing in front of you. It says converse of the Pythagorean theorem, and I'm going to zoom in here a little bit. And these are pretty much the same sort of problems we were just working on. Okay, tell whether each triangle with the given side lengths is a right triangle. Okay, so are these right triangles? So I'm going to use the Pythagorean theorem, right? A squared plus B squared equals C squared. the sum of the squares of the legs equals the square of the hypotenuse. Okay, let's check this out and see if it works. So 14, 23, and 25. Again, this one is C because it's the longest side. So over here, kind of same idea. Got to pick the longest one for C. Just that's really important to remember that. So 14 squared plus 23 squared equals 25 squared. So if I square these values, right, use your calculators. This is not 14 up to equals plus 23 up to equals 725. So the sum of the square of the legs is 725, and if I do 25 to the second power, it's 625, or 25 times 25, 625. Because those values are not equal, because a squared plus b squared does not equal c squared, this is not a right triangle. Okay, on to the next one. Same idea here, right? We're looking at, we've got three side lengths. We have three known side lengths on a triangle, and we want to know if one of the angles is 90 degrees. Is it a right triangle? Okay, so I substitute my values. Again, the long side, or C, is 34, so I put that right there. And I have 16 squared is 256, plus 30 squared equals 900. And 34 squared, or 34 to the second power, 34 times 34, is 1,156. Okay, these two values are equal. This is in fact a right triangle because a squared plus b squared equals c squared. And I know I'm going a little bit fast right now because I did this work, and I'm just laying it out to try and make this a little bit quicker for you. Pause the thing and ask questions as you need to in the classroom. Alright, we did that one already. We're on to the next page here. Okay, we're doing the same thing again. Alright, just more practice. Practice makes better. Let's get better at problem solving. So first thing we're going to do is well, read the directions. Tell whether each triangle with the given side lengths is a right triangle. Trying to identify right triangles again. The converse of the Pythagorean Theorem, right? Over here, that tells us if this is true, then it must be a right triangle. So let's look at these. You can see I've already got some answers in front of me, right? And I write these things down because the more I write it and say it and see it and do it, the better I understand it. The hypotenuse is the long side. Trying to understand all that new math language. It's called C, okay, in math land. So my sides are 27, 36, and 45. So my long side is C right here. So I'm going to put those other two values in either place. It doesn't matter. 27, call it A. Square that is 729. 36 right here. Square that is 1,296. Right? And if you don't, if I maybe made some mistakes, 7 up to 729 plus 36 to the second power is 2025, and 45 to the second power is the same thing. Okay, those values are equal. So yes, it's a right triangle because a squared plus b squared equals c squared. Over here on the other side, you can see we did the same thing. Labeled all of these three sides, A, B, C. C is the long side, or the hypotenuse, and then we find the sum of the squares of the legs, A and B, is at 445, just kind of following the steps down here, and then c squared, well, c was 21, and square that is 441, and these two values are not equal, so this is not true, so this is not a right triangle. Alright, we're going to keep going here, we're going to keep rallying right along with a little bit more. Now we're going to add a slightly different dimension to this. Okay, we're going to add some words, so we have to interpret what's going on here and figure out what we're being asked. Katya is buying edging for a triangular flower garden she plans to build in her backyard. Okay, so there's a triangular flower garden. The lengths of the three pieces of edging that she purchases are 13 feet, 10 feet, and 7 feet. Will the flower garden be in the shape of a right triangle? Okay, so is this flower garden going to be a right triangle? Now remember, the long side is going to be C, and the other two sides, it doesn't matter if they're A or B, but then we work that out down here, right? I take the Pythagorean theorem, a squared plus b squared equals c squared. Write it as many times as you need to remember it and understand it, and then substitute the values that you've assigned. 7 squared is 49 plus 10 squared is 100 equals 13 squared is 169. That is not, in fact, true. The garden is not going to be a right triangle. None of the angles of that triangle are going to be 90 degrees. Okay? Pause the video as you need to. I'm going to slide right on here to the next one, and we're doing the same thing, right? This page still says concept 12.3. It still says converse of the Pythagorean theorem. So I'm going to read this problem and we're going to work through it. We're going to get better together. A blueprint for a new triangular playground shows that the sides measure 480 feet, 140 feet, and 500 feet. Is the playground in the shape of a right triangle? Explain. Okay, and for any time it says explain, there should be some words. You need to explain your answer, your reasoning. Okay, is it going to be a right triangle? It's not a yes or no. It's not yes, this will be a right triangle either. It's this will be a right triangle because the reason this is true is, okay, so we've got 3 side lengths, 480, 140, 500. My long side right here, the other two don't matter. I plug my values in. I can write this again, a squared plus b squared equals c squared. And then I put my values in 140, 480, 500. And I find when I type those into my calculator, which we all need to use, right? These are big numbers. 140 up to 19,600, okay, plus 480 up to, just double checking my work here, 250,000, and 500 up to equals 250,000. The playground is in the shape of a right triangle because a squared plus b squared equals c squared. The square of the hypotenuse, c, is equal to the sum of the squares of the legs, the short sides. They're adjacent to the right angle. Okay, adjacent to the right angle. Adjacent is next to. That's what we're talking about here. Okay, ask questions if you need to. You know where to ask. One more, and then we're going to be done with these notes for the day, and you'll do a little bit of practice on your own if you want. All right, so concept 12.3, converse of the Pythagorean theorem. If this is true, it is a right triangle. Okay, one more time there, converse. Just works the other direction. It's working the other direction with that same theory. Okay. A triangular piece of glass has sides that measure 18, 19, and 25 inches. Okay, it's got 3 sides. It's a triangle. Is this piece of glass in the shape of a right triangle? Explain. So I got 3 sides. Long side is C, 18, 19, and 25. Plug those values in right down here. Add the squares of the legs. Is it equal to the square of the hypotenuse? No, it is not a right triangle because these values are not equal. Okay, thanks for being here today. I appreciate you all and the hard work that you're doing. Good luck with the homework assignment and the exit ticket.